Hi, folks. And there he is. Right, so I just started the stream. Sorry for coming on late. Raul, how are you? Are you all right?
I'm good, thank you. And you?
For some reason, I can't hear you. This might be me. Yes, it is me. Hang on. Hang on. Now it's the right microphone. And hang on, I can't hear you, so just keep on talking.
Okay, can you hear me now?
Okay, it's technology.
Yes, no. Is it ready? Can you hear me?
Yes, I can. Hi.
Okay, perfect.
So
I thought that maybe it was me.
yes. So thankfully I don't do anything with technology. So otherwise this would have been a bit interesting. Anyways, so okay. Hello all. I keep it short and sweet as always. If you like what you see, click this like button. If you don't like it, tell me. Don't click the dislike button. And if you haven't done so, click the somewhere is the subscribe button. This is all I have to say about the maintenance. And I will happily hand over to Raul. So thanks, Raul, for joining. And it's all yours.
Thank you so much. Cool. So yeah, let's start for today. Today we're gonna see my story about getting ready for declarative UIs with Unidirectional Data Flow using Kotlin Coroutines. So let's see what we have for today. So let me first introduce myself for the ones that don't know me. I am Raul Hernandez Lopez. I work as a software engineer at Twitter for the last 3 years. And if you want to follow me, I am actually writing some posts sometimes, so maybe you find it very interesting or not. But that's my handle on Twitter. And also, if you want to see some content snippets and anything like that, in GitHub, you also have my handle right there. But let's see to the important bit, which is the agenda of today. So I'll introduce, first of all, the use case where everything hopefully will make sense to you. Then I'll start analyzing and assessing architecture for this particular use case. Then I'll do some adaptation of this unidirectional data flow in order to have this in a way that makes sense, hopefully. And once this is designed and we have a clear idea about what we want to do, then I'll do some implementation details and then applying this unidirectional data flow to that. Then in the later sections, we'll see what I learned along the way and why Compose can be a matter of choice for you on Android. And if we have any next steps, we also see them after the very end of the talk. So let's see, first of all, the use case. In the use case, as you can see here, I am trying to type a query. So I am starting to type, I do something wrong. So spinner happens, also an empty results text happens, and you can see there are no results for this particular query. Then tweets with flow happens, and I have some results. First of all, because I have an offline kind of state, I saw a message, and then when the new results coming from the network, then I saw this particular tweet, and then I can see the detail. So that's basically the use case. And now let's analyze a little bit what I have here for the existing architecture. So to start adopting in an existing architecture, we have to go step by step because it's usually not that typical to do that. If you are in a brand new app, it's easier, but in a previous one, then you have to take a look at the different details. For instance, what I have at the time is this data layer that is composed by a repository that is managing different data sources. Those data sources, as you can see, are the network and the database data source. Both of them combined are the repository managing them. Cool. And then the use case performs any business logic and returns values. So that means that into the business layer, we have a use case that is getting and requesting information to the repository. The repository is returning the results, and the use case is basically transforming and processing anything in order to drop the results back to the presentation layers. So basically, by means of the callbacks, we'll have this done. Then next, when we are connecting the architecture coming from the use case, repositories, and so on with the presentation layer, what I have at the time is a MVP or model view presenter with a connection with the clean architecture. So basically the presenter for me, which is written in Java, as you can notice right there, executes the use case, which does the process I mentioned a moment ago. And then typically in architecture, what you usually do in the past is basically passing the callbacks from the use case to the presenter and so on and so forth. So basically the presenter is the connection between the business logic and the views. The presenter also passes this callback to the views, and then the view receives the new data and then is doing anything else. So you can notice here as well that both the presenter and the view are written in Java. Then if we think about the user intention, the user starts typing a query of interest, and then everything starts from this point. So for instance, by starting this, the system interacts by searching for a query, reacting to the different queries, and when it's different, then starting the presenter. This is something I do into the view delegate that basically is a delegate of the view with the delegate pattern, and that's the different mechanisms that you prefer. I wouldn't dig into details today about the view delegate, but this is where everything starts. I will do it basically from the use case. So now let's analyze the different coroutines that we have along the way into this particular architecture. Starting from the data sources, what we had is a suspend functions. So basically anything that I need from the network data source for me gonna be a suspend function, which means a particular single SOT request. And I will request as many times as I want the network data source, so that means one time. Then the same happens with the database data source that is connecting the results, and the repository is managing those things and emitting the values as they go. So basically, that's why repository could be a flow in this case. And then the flow is being passed the results to the use case. The use case actually then is the one in charge of collecting those things from the flow and then emitting those values in the way we prefer. The results are going to be there. So now, how to get ready for declarative UIs? Indeed, now we need to check and we need to think if the callbacks are the best way to approach this problem. Because now coming from the use case to the presenter to the views, callbacks works for both Java and Kotlin files, but probably it's not the best approach. We'll see in a moment why. So do we find any disadvantages on callbacks? So indeed, we do. The lack of readability of the callbacks is something that probably you notice. You worked with Java and concretely in Android for a few years now. So that's why we have a guest today. We have Ryu from Street Fighter doing this Kamehameha, and then having this super big indentation. And probably you have this problem in the past where you couldn't find where you were, you didn't know which callback you were in, and the callbacks were into callbacks, and those callbacks into more callbacks, and inner callbacks were happening all the way down. So actually callbacks break a very interesting principle called reference transparency that actually comes from the functional programming world. The definition of that is basically the ability to make larger functions out of smaller ones through composition and producing always the same output for a given input. So that means you always have this input, you will expect always this output, but if you change the input, you will have a different output. But for the first input, you will always have the same output. In that way, you guarantee that you are not affecting the things by having this principle respected. What consequences do we have if we break this principle? So for instance, thinking in the callbacks, we don't have a return value. So we cannot actually guarantee that the returning value or the output is the one we are expecting because we don't have anything to look at. Also, results are declared as input parameters into the callback, which is not ideal because then you don't have something to test about. So actually you cannot do unit tests with callbacks. You can just do integration tests with mocks. So up to you really to use them if you want to, but I would then go to that direction. So results actually can mutate very easily. And if you remember this callback out, you don't really know where you are. So if any of those callbacks, something changed, probably you don't know where because you don't have an output to check if this changed. So you can amend this problem. So lack of determinism is the problem. You don't have a guarantee that there is an output for an input. That's determinism, something that's gonna start and gonna end in a way. maybe you wouldn't start ever. So are there better alternatives to callbacks? Actually, we think in what we have nowadays. Indeed, I will say that in Kotlin now, by using Stateful, we have something that is very valuable, because by using Stateful, we're going to have always a latest value guaranteed. So that means if you change the Stateful with a new value, then you will pass this through. If you wouldn't change it, or anything into this Stateful that you already passed didn't change, then you don't have to emit any values. Also, Stateful is immutable by default, because Stateful as itself is basically an interface. That means when you pass the instance of the Stateful, passing this as a Stateful, you wouldn't get a setter, just a getter. So that means that Stateful is deterministic by default, and it's a good tool to use in this case. So basically, to replace the callbacks with Stateful, we're going to have something like this. The use case passes Stateful, the presenter passes Stateful, and it goes to the view delegate that passes this Stateful as well to the view. You can obviously, into your diagrams and your architecture designs, omit some values over here. This is just an example, of course. And the thing here, if we cannot really change the views for any reason, like I am suggesting here that I couldn't, then you need obviously to collect the value of the Stateful with a Kotlin file. Otherwise, you couldn't collect it. That's why I created something called Stateful handler. Now let's see the important bit of this presentation: how to adopt unidirectional data flow in a way that maybe makes sense. So first, what does it mean, unidirectional data flow? Is as simple as that. Only one way, only one direction, from going to this point, all the way down. If you finish here from this state, you can start from here, but then you have to go all the way again to this point. As simple as that. So basically something like that. You have a UI. The UI intends an action. This action transforms those results into a state, and this state will render the UI. So basically here the clue would be to have as many states as UI screens we want to render, to have a state corresponding to one UI. So thinking into the classes that I suggested previously, we have, for instance, an imperative UI that's a search view that intends a particular action, and then the view delegate triggers this action to the presenter executes the action, so the use case gets into action as well. And let's assume that the use case returns the value from the repository. We don't need to dig into that. So you basically pass from the action to the state. So basically the use case will dispatch state and will pass this Stateful handler this to the imperative UI in this case, communicating that state and rendering this into the imperative UI. Cool. So that means that imperative and declarative UIs can coexist. And why is that? This is because if you try to make things with states, what you can do is basically adopting a unidirectional data flow, and then you get ready for that. Because if the imperative UI is ready for a state, also is a declarative UI. And then you could use compose in your very legacy architecture, because you transform your workflow into an understanding way to use states. Advantages of this approach, under my opinion: flexibility, because now you have a way to make states, and this can be used both for imperative and declarative UIs. Reuse composition, because if you create smaller entities being used into other entities that are bigger, that means that you are using composition between layers, and then you can very quickly and easily change different interfaces for others, and then composing this in a way that is not disturbing other teams as well. So let's go now to the implementation details. About the data sources and the network database, what we have here is that basically I use suspend functions, as I mentioned a moment ago, passing those results back to the repo. What does it mean into the code? So into the network data source, I just have a Twitter API that's a retrofit client, something to check if I have connection, something to parse the response and the requests. And then the function, that is a suspend function, gonna get as an input parameter a token. That's because it's authenticated. I will basically query for something, because we were typing this, if you remember, into our search mechanism. And I will pass this back to the header. And header is basically the arrow operator header. what does is basically something similar to calling result. Into the left side, we have throw all, something that is a problem, an error. And in the right side, we'll have the results that are coming from the API. Then the same for the database. Into my DAO, I just pass a list of tweets with a suspend function using room. In this case, you could use something else. And that should be all for this particular layer. So now going to the upper layer of the data layer, we have the repository, and this uses suspend functions and flows. So basically that we are here. So flow and suspend functions, and let's see how we can manage those. Into the repo, I just have my data source that you already know and the different tables, tweets, token, query, combination of query and the tweets, a mapper for those to be combined between layers, and the task threading, which is basically a wrapper that contains the different dispatchers for you to use. Then I am returning this into the database when I need it, in the case I need a flow. Cool, so now let's explore a few cases. When we have, let's say, a get search tweet functionality with a query that the user passed, then probably we want to have some results. I am getting the results from the database. But what I am trying to do here is basically getting a flow inside a suspend function. Is that even possible? Can we do that? Actually, no, because a suspend function, if you remember, is a one-shot operation and flow is an open stream. That means that one more emission can happen. So this is not possible. Suspend functions only could be into another suspend function or a coroutine context. Something like that is actually possible, just passing a suspend function within another suspend function, or returning this list of tweets that is a one single operation. That's going to be the other thing for the database, nothing else. And then let's see, cases with flows. For instance, by using the flow builder, what we can do is emitting all values. If we have a poll refreshing every 30 seconds, then you could perfectly do that. And then the UI could be refreshed when a new value is coming and is refreshed with each poll. Also, very interestingly, flow on is an operator that is working upstream. That means that anything that is in the top of the flow on gonna be affected by this dispatcher, which is the input output dispatcher. Perfect for databases and network operations. Then this another case is also possible, emitting a one only value. However, if this is one only value, then it doesn't make any sense to pass this by means of a flow because you have suspend functions for that purpose. So you are wasting resources basically. The other case is when you want to emit the first values, the dirty values from your database before those were updated. And then when you update them with the network resources, then you can emit again, and those going to be refreshed, and you emit twice. That's perfectly fine to do. Now, use case and what we have there. Into the use case, we're going to collect the flow, transforming anything, and then returning those results back. And then connecting those with the placenta, with the callbacks, which are all the way down from the use case to the placenta to the view. Cool. So that was the first implementation of the use case with the callbacks, with a retained scope for rotation and those kind of things. So the tweet repository going to be there, and also the scope that is for this particular use case. And the contract means that we use the callback for that. Now for the coroutine scope, I define this with a scope that is a coroutine scope composed by the dispatcher of the UI, because we are collecting into the UI, and the supervisor job. The thing with the supervisor job that is interesting is the fact that if we combine this with the scope, then we can avoid other synchronous cancellation. Meaning that if you have any problem in one of the jobs, one of the particular tasks that you have over there, and it's throwing an exception and it got canceled for any reason, then job 2 and 3 keep running. And that's a good thing of supervisor job if you don't use a lifecycle owner or something like that. Otherwise, you don't need something like this suggestion over here. So the use case implementation. We have the use case with this callback that I mentioned a moment ago, and the cancellation of the scope if it's needed. Then for the callbacks, I just initialize the callback. I show the loader, the spinner that you saw into the first GIF. And then the scope launches the coroutine. The repository searches for a query, maps any computation if it's needed, and then the flow on gonna act because it's upstream and will do any computation in the computation dispatcher. Then we'll catch any problems, we'll pass it to the callback, same with the collect, that's gonna collect the things that are right. That's in when we have any results. for every particular action in the stream. And we'll pass this by means of the callback in this case. Equivalent to this particular one, we have on each that is equivalent to collect, but the difference is that you use launch in instead of scope.launch. And you have the ordered change, and also the catch is catching any problems upstream as well. So again, the scope is here, and we cancel when we need to cancel it by using also strata concurrency, of course. And now let's see synchronous communication with the UI. So it's the time for maybe removing the callbacks. So callback is going to be replaced with Stateful, and this is all the way down to the view. So we can change the use case that had this with the callback, and we use something else. So we don't have the need of using a callback anymore, and we can have the get Stateful over there. And Stateful can be passed across Java and Kotlin files. So this is very nice because then we can use it in hybrid projects. Now in my contract, I have this UI state that we'll see in a moment, and I'm gonna pass this by means of this Stateful that is immutable. For the instance creation, we have mutable Stateful that's gonna create this instance for us, and initially it should have a state. That's why we need to create that. Remember that Stateful always returns the latest value, so it needs to have at least one value. And then we expose the Stateful, which is gonna be immutable. So Stateful gonna use distinct change by default because by default it has it. So if you apply distinct change, it wouldn't be applicable because it's already there. Then the shield class that I defined for the different states when I was modeling my states are list results UI state, where I pass different tweets inside this data class. And then, super important, we need to define this with val, because if we have var for any reason, then there is no way that compose knows under any precomposition that you had this change. It needs to have all immutable values. Otherwise, you're going to have troubles, and you wouldn't know why this changed for any reason. Same for the other ones. So if the error has a message with an error message in a stream, then we also have this with val. Then if we have an empty state that we want to say like, hey, I didn't find this particular query, the same, we pass the data class with the value that is a query. Then finally, loading state doesn't have any parameter. And idle UI state, if you want to show something, or maybe not, but you have the first state that is there. Because we define all the states, then we can start changing the things with the callback. And the first thing is maybe applying something more declarative for flow. So basically using on star is a good thing. We could pass the value by means of the setter of the set value. So we pass loading UI state and we got it there. It's gonna be very, very fast. Then if we want to have every single iteration of the stream, then in on each, we can pass those tweets that come in and see if you sent it to pass an empty UI state. Or maybe we want to pass the results with the tweets. So we do the same and we set the value. Equivalent to that, we have the catch operator, catching any problems, and passing the error back with the message. Cool. So now we are here collecting the state flow. So let's go to the way down to where we can collect it. So first of all, the placenta. I promised you that it was in Java. So here we are. We have the use case that is injected right there. We cancel this from here if we need it. And then the state flow gets exposed as well from the placenta. And the main functionality here is basically searching for tweets. So I can remove very safely the callback because we don't need it anymore. And then I can just execute the query and making sure that I share with my shareholders that get state flow anywhere that I need it, because the state flow is going to be there for us to be passed across different Java and Kotlin files. Now the state flow got passed from that to the delegate over here. And with that, we have this cover until the next element. Now the fragment, because a fragment or your activities or anything else that is your UI gonna contain both the delegate and the handler that I used. So basically there, I initialize my things and I get the state flow and I pass this to my state handler because it's the one that's gonna be collecting the things for the view. And the state handler gonna do that for me. So also in our create view, I initialize this function. And here we are, we have a handler, also initializing the state flow inside that with the parameters that we passed. That's the reference to the fragment plus state flow. So basically, every iteration of the state flow that we emitted is being collected, every event, every action on each. And we are going to handle those states from the UI. Now, this is, of course, in our scope. Otherwise, you couldn't do it because it's a coroutine. And now let's see how we can render this into the imperative stateful UI. Stateful, because as you will see, we need to obviously set different things, different states into the view. So here we are passing the state flow is there, it's communicating the state to the imperative UI. So handling those states with the UI, we're gonna get the list results UI state. So we need to define a extension function as well that is going to do the show results, passing the tweets. What do we have there? Something like this. We pass the tweets and we start doing fancy things with the view, right? We need to, first of all, hide the loader because it was visible. Then we need to hide any errors because they were probably visible as well under the hood. We need to show the list because it was our cycle view with many elements like layout, manager, item decorator, and so on and so forth. And now it is visible. And finally, because we have this coming from the state flow, this list UI state, now we need to pass the tweets. Every single tweet gonna belong to a single view holder. So one tweet, one view holder that is into an adapter. And then this is going to happen. We need to update also the adapter, many things here into the imperative UI, handling state and managing things. So for the rest of the elements, it's very similar. So I'm not going to dig into details, but basically for the loading, you'll show anything from the load, but you will hide the rest of the elements. For the empty UI state, you will show the empty UI state, but you will hide the others. And the same for the error, unless you want to contain both at the same time, and so on and so forth. idle.ui state doesn't do anything into my imperative UI, so that's all. Now, going to the declarative stateless UI migration. Why stateless? Because declarative UIs don't care about state. They just care about rendering things with a set of rules. So what we have here is passing the state flow handler with a collected state, passing this to the declarative UI that we're gonna use instead of the imperative UI. Here we are. So we have the fragment, and the fragment contains something called search composables UI, which is containing all composables that I have, search view delegate, and then search state handler, the ones that you already know, of course. We need to start somewhere. So this somewhere actually is the layout. The layout is something that we're gonna need to be interoperable. Otherwise, you cannot really start. And the good thing is that Compose got you covered because we have something like Compose view that can be integrated very easily into the XML, and then you can start playing with it. Something like that. You're gonna create the view, and you're gonna basically find by ID this particular Compose view, and with that Compose view class, you can start playing with it. So basically, I included this reference and I passed this into my search composables UI to play with. So basically something like that. And now I'm going to initialize also my state handler with the state flow and injecting this composables UI inside. Because I did that, we have those over there, so we can start playing with the different things and features that we have. So basically the handler going to be doing this task for us. And then processing that. So that means that into the process, we're going to do the same. So basically into a particular state, in this stream, we're going to start composing the views belonging to this UI state. And that's the search composables UI with the setter that I already showed you previously, and the compose view that can be later on nullable, and start composing the views. For start composing the views, that is the method that we'll use, what we need to do is basically, for starters, using set content, because set content gonna be the first thing that we'll use in Compose. Set content gonna need to be with a material theme. And this material theme is the default one by the system. So preferably you want to do something like this, like creating your own with the particular subset that you prefer. I won't dig into those details today, but you need basically a theme to start with. It's like suspend functions when you need another suspend function or a coroutine context. The first thing in Compose is a theme and then other composables. That's it. Now you have states UI, and the states UI gonna pass this UI state, and this is gonna be our first composable right there. So this is it, the states UI, passing the UI state, and then checking what state is that, and then we need to start from this particular bit. So this state is gonna be the first one that we are going to implement in Compose. So let's see, declarative, stateless UI, and some alternatives. So also we could use the use case, passing the UI state handler, handling those UI state, and passing this to the declarative UI. Then we need to collect the same, and we'll pass this over here. So now we don't need to have this over here. We'll pass the search UI state handler. We'll set the compose view again right there. And then we'll have to do basically the same. You can see I just removed the parameter that I have in state UI because I'm gonna pass the Stateful in another way. And then what we have here is that we can basically collect state directly from the Stateful. So basically we have a very handy operator that can be used into composables that is collect as a state, and it can get very easily a state that is understood in compose. This is very interesting because then we don't need to do the collection ourselves. We can just rely into that, and this will get the state that's going to be passed directly by means of the value, the category of the value, into the state UI value. So now we can go to the rendering of this stateless UI. We have the state UI value that we saw a moment ago, and then we go to the first of the states, of the UI states, the list results UI state. So I define an element that is another composable function that gets and has a tweets grid composed by a set of tweets, a list of tweets, and it's something like that. Basically, I use a lazy vertical grid with a modifier having max width, and then a couple of cells, one for different columns. This also can be adaptative. This is actually kind of temporal implementation. This is not still stable, but you can use the items. So the items use the count, tweets get the size, the item content get the index of those elements, and then we can start digging into the different tweets. So basically, the tweet gonna be retrieved and gonna be used into the tweet box. As you can see, the lazy vertical grid is composed by the items. We have the count, the item content, and then the tweet box. And also what I passed right there is the click functionality into on tweet click with the tweet as a parameter, something very easy as you will see right now. So on tweet click, basically just does a click. It's a lambda, returning a lambda as a function that we pass as a parameter. And we just make sure that the tweet has the right details, and then we navigate to that. This navigation is to a normal activity before compose, but you can use something else, so it's actually compatible as well. Now for the tweet box, every single item that we're gonna render, we have the tweet and the on-click action that we can define and we can assign to the clickable. We make sure that it's wrapping the content with, in this case, creating a border, a little color, a little shape, so on. And then aligning this to the center as well. Now, because I started with the column, you can see here what is the result of this particular screen. So basically, column is, in a sense, if you are familiar with the regular Android views, kind of a linear layout where you just define the elements and then you put one after the other. So I have the box, then I have the column, and the first element, which is the image. The image in this case contains a few things right there. So first of all, I have a request to the image, of course, because I need to get this image from the internet. And then it's remembering the call painter, because the call painter actually gonna get the image. And unless there is a change into this image URL, it will use the same image again. And then you don't need to recompose again every time that there is a recomposition in compose. Then I use a modifier for the size, but that's all really for the image. Also, very interestingly, we have content description. So that means accessibility first. Accessibility is important. Please use it. And it's compulsory to use it here. Otherwise, you cannot really go forward. So this is awesome. We have also accessibility options in Compose. And now we have other two elements, spacer in between the elements, and then center text with this particular text for every single person. Then describing the rest of the states. What I have there is the loading UI state, with a particular string that I pass. It's a string coming from the strings XML, the empty UI state with the query that we know that wasn't successful, and the string that is completing this with the query. And then finally, any error coming from the UI state as well. Then looking to the center text, which is a generic element I use for everything. As you can see, it's very easy to reuse, and it's as simple as just this text with 4 lines, nothing else, with ellipses, and that's all. You can use it everywhere, and you will have something like that. There are no results for this particular one. Then the final one is just the idle. I just put the top text, and that's all. I will describe this because it's very similar to the previous ones. Then to finish, just cleaning up resources. So making sure that if you have any reference to the view that you didn't nullify, you need to nullify it to avoid memory leaks. Same with the scopes. If this is manually like I did, then you need to cancel those scopes. Otherwise, you can rely into your lifecycle scope or whatever you use on Android or architecture components. And then destroying the views in every single element, of course, for the activity scope, and destroying the view, of course, invoking those methods. And with that, you have Declarative ready with Unidirectional Data Flow under the hood. So basically, this is the final result. Start typing is the top center that I mentioned a moment ago. And this is me typing something in Compose. And here we are, getting the results, refreshing, and we can go to the detail by clicking one of them, and you can see the results with the hashtags. So we have the initial text, the loading text, the empty results text, issue results, and error text. And this is actually much more small into lines of code than regular imperative UIs. So now let's see the important bit of this presentation under my opinion, which is basically what I learned. Interoperability. This is really awesome in Compose. You have both ways. So that means, like the example I mentioned, Compose view can be used for integrating into previous layouts. And if you have the other example where you want to start a new screen from scratch, then you can actually start from scratch. And if you need to use some particular custom view that you love and you don't want to get rid of it, you can use Android view, which is another one, and you are covered with that, really. Recomposition runs multiple times, and that means that is meant to be fast and very performant, meaning that if you have some code, you need to make sure that you do the right thing most of the cases. Otherwise, you can get into trouble of running things many, many times, and those maybe are resources that you're gonna leak in some way. Also important to think, remember, we'll save a previous state into the view. And that means that if you now need to change something because there was a click into a button and you need to save it, there was a switch that you need to save, remember, we'll do that for you, and you can save whatever you feel that you need to save for the next recomposition, and it will be there for you. Composition local is also a very interesting concept that Compose gives us. It's actually the simplest way to pass data flow to the tree and its children. So that means if you don't want to pass a parameter into all inner composables, you can use composition local to only provide this particular composition to one of the sub branches of your tree or the slot table. Meaning, as simple as that, if you are familiar with dependency injection, this is a kind of dependency injection, basically, in an upsell. Composable should be side effect free. What does it mean? That means that preferably you don't want to have side effects into your composable for avoiding memory leaks, waste of resources, and so on. So the best thing you can do if you want or you need to request something to the network or the database is using effects handler. There are a bunch of them. Those are very useful, and you can use them into Compose. This is actually making sure that after every recomposition, you can run a side effect without affecting the performance of Compose, and that is great. Unidirectional Data Flow likes states, but really, really likes states. That means that because we don't know the order of the recomposition elements that you have into the UI, you need to make sure that the UI that you are rendering can be a single unit. That means that you render all as it goes. That doesn't really rely in a particular order. Otherwise, it's a problem in Compose. Now, going to the interesting part of the imperative against declarative programming. This is always super interesting to talk about because with Compose, we do this kind of declarative way, which is a change in the mindset. We need to make sure that we are doing the right thing, being very explicit, because the declarative paradigm is more about what you do, but not how you do it. However, imperative is more about how you do it, implementation details. That's why you need to set particular state, like the visibility or something like that. So this is a very interesting kind of mindset and gonna help us to drive our mindset towards states, basically. So in the end, just answering the question, why Compose? Why do I need Compose if I was super happy creating files, XMLs, layouts of 3,000 lines? Why I want to get rid of them? Well, Compose is very nice because runs in parallel. That means that very frequently I'm gonna get these kind of things improved probably in the future. Classic views relies into a sequential order. So you want to render or inflate a particular view, then you can rely into this sequential order. So those things are things to take into account when you change to Compose, because otherwise you're going to have unexpected very side effects probably. Then Compose is stateless, as we know. Only if you pass an immutable variable, anything will change. Otherwise, it wouldn't. But this guarantees that there is determinism right there, because if you change something according to an input, then you are deterministic. You have reference and transparency. You make sure that everything is as you expected previously. And you can test it, because otherwise, if you don't have determinism, you cannot really test things. So classic views are stateful. That means mutable, and that means unpredictable. Why is that? Because if you have a super big hierarchy of views, let's say an XML with custom views, with several switches, with another custom view inside, with a connection, probably you don't know where you lost control of those switches, those states. It's very similar to the callback paradigm that is helping us to misunderstand everything. Then Compose can run only in Kotlin, but classic views can run in Java and Kotlin, of course, because the classic views belong to the OS, but Compose is a library on the top of the system. So that's the main difference at the moment. Now, performance improvements. Compose is meant to be really, really fast. Actually, in certain cases, according to the Google team, it's actually faster than regular views. Of course, there are others that is impossible because it's part of the OS. Testability. If we make sure that we are using unidirectional data flow, that means that we are decoupling things, that we are making sure that the states are the things that we are expecting for a particular screen. So that means that until you arrive to the UI, you can actually test everything, because you are basically transforming into a state that you, until that point, gonna test. So if a state means a screen, this screen should belong to the state. So the only thing you need to test when you go to Compose is that the screen is what you were expecting to be, nothing else, because it wouldn't change. You are having this set of rules that you are completed, and then you have it. And that's why you can use snapshot testing. And with that, you can be confident that this is going to be the thing that you were expecting. Same with expression-like tests. You're going to test the things that you're going to have on the screen, and that's all. Reusability of UI components is super, super, super simple to create a particular screen, particular element in Compose. And you can extend very easily those elements, and in fewer lines than previously. So for creating something like a recycler view, you remember my example of today, I use much less lines of code for sure. So that means that it's quite reusable and very nice to use as well. Also, Compose enables us to experiment a little bit, because with new ways like backend-driven UIs, you could basically have this with your backend, and very easily you can create one state, another state, and defining the states into your backend. And then because you process those very easily, you can just say like this particular set, it belongs to this state, and then I can render those things into my UI. Of course, with classic views, you could do something similar, but then you need to create much more lines of code, much more files, using intents all the way down, and of course, more complexity. Next steps. start adopting explicit state declarations today, because if you want to migrate to Compose and you are waiting for the release to be stable, then probably you're going to be a bit late for migrating your whole app. It's better to start little by little and go into the different Compose views, playing here and there, understanding the paradigm, because it's super different imperative than declarative UIs. And this is a game changer, actually. Then finally, a few resources and references that I have for you. I wrote 3 articles for this series, Getting Ready for Declarative UIs. And then you have also an article specifically for the Stateful that is also a combination with the part 2. You can get a very good feeling of the Stateful. That's all. Thank you to Nick Patcher for reviewing the first series of these slides back in January. Thank you for being today and being with me today. Hope you enjoyed it and it wasn't too long. And if you have any questions, I can be here for you.
All right, so yes, we got a question from Carlos, and he asks, in the Compose documentations, suggests to avoid architecture patterns like MVP. What do you think about this? And then he quotes from the Compose docs, UDF architecture patterns work seamlessly with Compose. If the app uses other types of architecture patterns instead, like MVP, we recommend you migrate the part of the UI to UDF before or whilst adopting Compose.
Very interesting question. Yeah, of course. The thing is that this is an example where I didn't change my architecture. So basically, if you know what you are doing, probably it's not really a big deal. You can just change when you are prepared to change. Of course, there are patterns that are better for, DOM for Compose and Unidirectional Data Flow than MVP. MVI is one of them, of course, more than actually MVVM, because MVVM in the end is the model view model is basically that we are using in architecture components, but actually the MVVM is very similar to MVP, just like we have very nice things with architecture components that are making our life easier because it's done by Google. But in the end, it's very similar MVP that MVVM, and of course, MVI pattern is the closer to what Unidirectional Data Flow aims to. But it's just an example, of course. So everyone is more than good to go with their preferred architecture.
All right, I hope this answers the question. The first thanks coming in. I definitely have to chime in there. Really, really nice. I love your slides, by the way. Yeah, so let's give them a couple of seconds. Yeah, let's see if any other questions come in, but it looks like you answered all of them during your talk. Anything you would like to say?
Well, thank you for inviting me today. It was very nice to see you again.
Likewise, long time, mate, long time. It's about time we can meet in person again.
Yeah, indeed.
Okay, cool. So Carlos just gave his thumbs up for the answer, so I think this was completely spot on. So thanks for being on. Really enjoyed it. Hopefully we can get you back soon. And if you don't have anything to say, I say thanks again. Thank you for joining. Thank you for being on here, and stay tuned for next month's talk then. Have a good one.
See you.